Yes, let's start with 17 on 383.
Or actually, make it 20.
Is it on the checklist?
No. 18 is
Okay. So let's start with that. So
20.
today, and we are looking at number 20 on 383.
Start recording.
Yes, I did. Thank you. Thank you so much. So x approaches infinity from the sum from xi star over xi star squared plus 4 delta x from I equals 1. Oh, n, of course. From I equals 1 through n. And they want the interval 1 comma 3. So the requirement is express the limit as a definite integral on the given interval. So this is the limit of the Riemann sum. So then obviously this is the interval that we have to work with. So then can anyone tell us what to do? This is the integral from a to b from f of x dx. We know that because the integral from a to b from f of x dx is the limit of the Riemann sum. All we have to do is put in what we're missing here. So what is this?
It's a b minus a over n.
So the integral from,
1 to 3.
very good, and the function is x over x squared plus 4 dx. Very good. Anything else? Is there anything else, other questions that you worked on?
That's all.
We're asked to present the limit of the Riemann sum as the definite integral. That's all we're asked to do. We're not asked to evaluate, we're not asked to find, it's just express the limit as a definite integral. Anything else? So let's take a look at what we have here, and we discussed all these, but so we know that the integral from a to b is the opposite of the integral from b to a. We know that. We've used it in part 1, correct? We also know that the integral from 5 to 5 from f of x dx must be, yeah, there is no area from 5 to 5. Right? So if the limit, the lower limit and the upper limit are the same, the integral must be 0. Okay, and we used all these, so there is nothing here. But I wanted to talk about comparison properties and work on a problem with you. So again, they are common sense. So let's say that f of x is a function that is positive on an interval a comma b. It's common sense that the area, which is the integral from a to b from f of x dx, must be what type of number? Of course, it's just common sense. That's the first property. The second property, also common sense, if we have f of x greater than or equal to g of x on the interval a comma b, then the integral from a to b dx from a to b dx must be greater for f of x, for the area under f of x, than the area under g of x. It's just common sense, right? So if I say that this function is above this function between a and b, obviously the area under f of x must be larger than the under g of x. So here is a picture of that. So let's say this is f of x, and I have g of x, which is here, and this is a and b. So obviously the area under g, which is the integral from a to b from g of x dx, must be smaller than the area under f. So that's what this means. If f of x on the interval a comma b is above g of x, the area under f must be greater than the area under g. Also common sense. Agreed? Okay.
Scroll up.
Say it again.
Yeah, I don't. Go back to the beginning of that,
Which part?
just where you started from. Is that, because I wasn't paying attention again? Can you say that again, please?
Where am I looking? Here?
Yes.
If a function is positive on the interval a comma b, the area under the function must be positive
Okay.
or 0. If a function f of x is above a function g of x, the area under f must be bigger than the area under g.
Okay.
If f of x is greater than or equal to g of x, the integral from f of x dx must be greater than the integral from g of
Okay.
x.
I thought I missed something.
No, that's fine. That's fine. Is this okay now?
Yes.
Okay. So another and the last property is if we have a situation like this. Here's a function, and I know that this function is bounded between two numbers. The lower number is denoted by lowercase m, and the upper number is denoted by uppercase m between the interval a and b. So let's suppose we have this situation. Obviously, if I write that f of x is in between m and m, the integral will follow, based on the previous property, the same rule, right? From a to b. In other words, I'm saying this area is definitely smaller than this area, which is definitely smaller than this area, based on the previous property, basically. Here I have two functions, but here I just have one function squeezed, if you want, or in between two numbers. But this I know how to find, because this is the area is b minus a times m. So all this can be replaced by b minus a times m. The middle part stays. And then how will I determine this? That's it. So these are three properties that we did not get the chance to look at. And now we're going to find some problems and work on this. And there is nothing else that I can remember that we missed or skipped or we needed to go back. None of that. Everything else is completely done, unless you have questions. Yep, everything. We did not skip anything. These were the only three properties that I wanted to mention. And now we can go back and practice. And then I'll do whatever you want me to work on. Okay. Okay, on page 384. Is that good or bad? Whatever. Good?
Oh no, sorry, my jaw hurts.
Oh no.
Yeah.
Okay. Okay, I see 57 in red, so they must choose that for a reason. Use the properties of integrals to verify the inequality without evaluating the integral. I cannot even evaluate this integral other than approximating it with rectangles. So we don't know an antiderivative of the square root of 1 plus x. Hands are tied here. So we can only try to show that this integral, whatever it is, because I can't determine it exactly, is definitely a number between this and this. It must be a number because it's a definite integral, but I can't determine it. So we are only asked to show that whatever this is between 2 and 2 times 1.41, between 2 and 2.82. Where do you think our starting point is?
B minus A.
Absolutely. But not in that sense. But saying that x is between -1 and 1, because this is very clear. I'm given that. So I have to start where I'm given something to work with. And this is what I'm given. I'm absolutely in the clear that x must be between -1 and 1. There is no discussion there. Agreed? Good. So now what am I trying to do? Here's what I'm trying to do. I'm trying to create this function. Right now I only have x. And I have this, which is -1, and I have this, which is +1. But if I can somehow create the function in here, then I can use this property and integrate all three sides. But I still have a long way. I'm not there yet. Okay. So then, remember what the function is. So I have to piece by piece, of course, with the square root. I have piece by piece construct this function in the middle. But of course, whatever I do in the middle, I have to do to the sides. I cannot just say, oh, I'm going to add 1 inside and not to the others, right? So I have to think and discuss this step by step. Thank you. If x is between -1 and 1, can we identify what x squared would be? Where would x squared be? And no, you cannot square both sides or all three sides. This is not how it works. Remember x between -1 and 1, when you square those numbers between -1 and 1, what is the smallest number you get?
0.
What is the largest number you get?
1.
Is that clear for everyone? Okay. So I created one piece of the puzzle. Now what should I do to all three sides to get closer?
Add 1.
Awesome, awesome. Absolutely. Now, and I'm not allowed to do this in all situations.
Is this like a special case where you wouldn't square the three sides to get the x squared?
Okay, so let's think one more time. If x is a number between -1 and 1, if you square those numbers, what is the small? You all get positive, right?
Yeah.
What is the smallest number I can get out of -1 to 1? The smallest possible. After I square all those numbers between -1 and 1, what will be the smallest number I can get? What will be the largest number I can ever get? So that's why x squared is between 0 and 1. Only when x is between -1 and 1. That's my starting point. Only for those numbers. And yes, I'm not allowed to square, especially when one side is negative. But I'm saying if x is a number between -1 and 1, and if I square all those numbers, the smallest number I can get is 0 and the largest is 1. So then, as long as x is between -1 and 1, x squared is between 0 and 1. Would you agree with that concept? Now, it's clear that I'm allowed to add 1 to all three sides. Is that understood? Okay, now, the next step is not legitimate in all cases. What is that? Taking the square root. Only if all three sides are positive. If all three sides are positive, then the square root of the first will be smaller than the square root of the second, which will be smaller than the square root of the third. So if you want numerical example, is 3 less than or equal to 4, which is less than or equal to 9? Well, the square root of 3 is definitely less than 2, which is definitely less than 3. So I'm allowed to do this only because all three sides are positive. So then the left-hand side is 1. The middle side is the square root of 1 plus x squared, and the right-hand side is the square root of 2. And now because that's my function. I had to stop. That's all I need. I need this function inside. I'm using this property that says a function is between two numbers. Here's a function between two numbers. And of course, between -1 and 1. So if I have a function between two numbers, the area under the first number will be less than the area under the function, less than the area under the last number. Would you agree? So now, the middle part, which cannot even be determined without a software, the left-hand side, what function prime is 1? Between -1 and 1, what function prime is the square root of x? Of course, I put the square root of x outside. Not the square root of x, the square root of 2. Times what? There is 1 here. It cannot be 0. X from -1 to 1. I don't have to do this because I know m times b minus a, right? But let's say we forgot. So I plug in 1 minus when I plug in -1. Plug in 1 minus when I plug in -1. That's all they wanted us to determine or show. That indeed, the integral from -1 to 1 from the square root of 1 plus x squared dx is between these two numbers. Yes?
So it was just proving the initial statement.
We were told to start somewhere and show, step by step, that the integral between -1 and 1 from the square root of 1 plus x squared dx is between those numbers.
Right, that's what
Yes.
that's all I was
Yes.
asking for.
Yes.
The answer, and it was telling us to find it.
There, yes.
Okay.
We were asked to show that this is true.
Okay.
Yes, yes. Any questions? Any questions? Okay, can I choose another?
Sure.
Okay, so on the same page, 59. And we have the square root, I'm sorry, I jumped to the square root instead of saying the integral from 1 to 4 from f of x dx. We can determine this exactly because I can determine the antiderivative of the square root of x. That's not a problem, piece of cake. However, they say do not find the exact integral, just estimate it using the previous property. So where do I start? Where's my starting point?
X. Greater than 42.
1 greater than or less than 2.
That's the starting point. That's what it says. The integral from 1 to 4. So x is between a and b. Very good. Good. So then,
Square root.
yes, because everything is positive. I'm not allowed to apply the square root unless I know that all sides are positive. Okay? So the square root of this, the square root of this, and this. Maybe I should have started with this example. So the left-hand side is x. Exactly. You're right. It's 3. Less than or equal to the integral from 1 to 4 the square root of x dx. And this is, yes, it's 2x from 1 to 4. So 4 minus 1 indeed the integral from 1 to 4 the square root of x dx. And this is 4 minus 1, 2 times 3, 6. So this is a way of estimating. We're not really determining. Can we determine exactly? Yes, of course. Because we can determine the antiderivative of the square root of x. Yes, please.
So did you get the 3 by subtracting 4 from 1 and multiplying? And then
The fundamental theorem of calculus part 2 says plug in 4 and then subtract when you plug in 1. Yes, the answer is yes. 4 minus 1. Yeah. Any questions on this? So if we want to determine exactly, is the integral from 1 to 4 from x to 1/2 dx. So this is x to 1/2 plus 1, which is 3/2 over 3/2 from 1 to 4. There's no difficulty here. Here you can torture me as much as you want. I will not be able to, without a maple or something or mathematic, or I will not be able to determine an antiderivative of this. I can't. So that was absolutely necessary if we wanted to estimate it or have an idea of what type of number or where it is. But here I don't really need all this because I can determine it. So this is 2/3. When I plug in 4, the square root of 4 is 2. So this will be 8, right? Square root of 4 cubed, and then minus 1. So this is 2 times 7, 14 divided by 3. And this must be a number between 3 and 6. Mandatory. But this is the exact. We're only asked to estimate it. So my estimate is that it's somewhere between 3 and 6. The exact, 14/3. Okay, I think we should start reviewing, and if we need more examples, and there must be a problem like this in that handout. So I think we should start. Or if you have any questions, I would like to continue with your questions. Anything you want? Yes.
Could you go over problem 65 on page 414?
65, 414. 413, 414, 65. So the integral from 0 to a from x, the square root of x squared plus a squared dx, and we are told a is greater than 0. Very good. Now, I'm looking at this problem and I say to myself, well, if I could make x squared plus a squared disappear from under the square root, I will like this integral more. So therefore, I will say let y be x squared plus a squared. And if dy is in the problem, then I'm on the right track. If dy is not in the problem or is too difficult to create, then I'm not on the right track. So dy equals 2x dx. I have x dx? Yeah. I don't have the 2, which is a piece of cake. Making up a 2 or a negative sign or 1/5, that's never a problem. So then I would say this is my dy, and this is the square root of y. So the integral becomes 1/2 y to 1/2 dy, and I know not to copy the limits of integration for x into an integral with y, or in y. So when x is 0, y is a squared. When x is a squared plus a squared is 2a squared. And I know
do that again. Explain that part again.
when x is 0, y is a squared. When x is a, I have a squared plus a squared, which is 2a squared. So then, is that okay?
Yep.
So then I have 1/2, again, y to 3/2 over 3/2 from a squared to 2a squared. I flip and I get 1/3. And now, when I plug in 2a squared, bless you, I have the square root of 8a to the 6th minus a cubed. It is a to the 6th. Yes, it is. Okay, so 1/3. Then I have 2. And it was 2 to the 3rd, the square root. Yes. Ooh, I have the square root. Okay, 2. A to the 3rd, the square root of 2 minus a to the 3rd. And you could write it as a cubed. 2 the square root of 2 minus 1 over 3. And again, there is no need, and please don't go back to x. There is no need. The result is a number anyway. It doesn't matter whether you evaluated the integral using x or y. It will just be an extra step and more work. And you cannot copy the limits of integration anyway.
Where,
Yes, go ahead.
where 8a to the 6th came from?
So I have the square root, but I have y cubed. So 2 cubed is 8. A squared cubed is a to the 6th. But I have to keep the square root. And here it's better because I have the square root of a squared, which is a, cubed, which is a cubed. But here I'm having a problem because I have to cube 2 and I get 8, and I have the square root of 8, which is 2 the square root of 2. Very good question. Is this better? Thank you, Stephen. It was a good one. Anything else before we look at this handout? Anything else? Anything else you worked on? Anything else you'd like to look at? So just to make sure, we decided that the test is on Wednesday or is not on Wednesday. I let you decide. I'm
This coming
fine.
Wednesday?
I'm fine with whatever you decide.
Oh, we're doing Monday.
Okay, so that's what I thought, but just to make sure. So then it means that the review for this test will be today, and then I'll start reviewing for the final
Wednesday.
on Wednesday. Of course, I will answer your questions first if you have questions about this test, but then I will start reviewing because just one lesson, one lecture, is not going to be good enough to review for the final.
And the checklist and all the 3 other things, they're all due Wednesday.
Wednesday,
Okay.
yes. I mean, not the bonus for test 3. I don't care about that. Later, I don't care. And the quiz later, I don't care. But I want the checklist
Okay.
Wednesday.
So we can hand the other stuff on.
Yeah. I don't care for that, unless you want to. But I would like the checklist so I can post solutions for you. Is that okay with everyone?
Yep.
Okay. Next question. Any type of problem, anything you would like to go back to?
I did just have like a general question.
Yes.
So on one of the problems that I was working
Yes.
on for the checklist, I
Yes.
saw someone do a substitution
Yes.
or something similar using trigonometric functions
Okay.
as opposed to substituting with a letter. So they, for instance, they did like the a squared plus b squared, and they substituted that with sine. Or in this particular case, of a
No, we
squared.
don't know trig substitution. This is in Calc 2. Can you point to the problem to me?
Yeah, it was.
No, we don't know trig substitutions yet.
It was 64 on 414. A squared minus
414,
x squared.
64. It's exactly what we just did.
Okay.
You don't have to do anything else.
Okay.
Later on in Calc 2, yes,
Yeah, that was confusing me.
but you don't have to at this point, no. We don't know trig substitutions yet. Good. Anything else? Do you have anything that you want to choose, or we go through this? Okay, very good. So let's work on number 1 for 1 minute. Do we need more time? Ready? Yes?
I was just gonna get
Yes.
10 cosine t minus 3 sine t plus 8.
So cosine prime is not sine, but negative cosine is. Prime is sine. So plus 3 sine t plus c1.
I want things to not.
So now s of t is,
Negative 10 sine t minus 3 cosine t
yes,
plus c1 t plus c2.
very good. So now I'm going to plug in 0 because s of 0 is 0.
c2 is 0.
That's 0.
That's -3.
Yes,
Oh,
and this is 0. Plus c2 is 0, which means c2 must be.
3.
So for now we have that s of t equals negative t sine t minus 3 cosine t plus c1 t and plus 3. But I have one more condition, s of 2 pi equals 12. So when I plug into pi, still 0. 2 pi,
-3.
yes, indeed, and plus 2 pi. So this is 2 pi c1 plus 3 equals 12. We did this problem together, I'm pretty
Well,
sure.
C equals 12 to that, C1 equals.
Yes, so it's 12, so it's 6 divided by pi. Very good. So then s of t, I think we did this problem together. Negative 10 sine t minus 3 cosine t, and then plus 6 over pi t plus 3. Are we okay with this? Everyone? Yes? Okay, so let's work on the limit of the Riemann sum. And you like the interval?
Yes.
Do you like the interval? I do too, because it starts where?
0.
Yes. need more time?
Yes.
I'll put the attendance in then. Are we getting anywhere? Do we need more time? You want us to start? Okay, so here's how I would address this. I will first determine the integral from 0 to 3 from x cubed plus 6x plus 3 dx in order to see what's ahead of me. I know this is not what I have to do, but I like to check my work anyway, if I can. So this is x to the 4th over 4 plus 6x squared over 2 plus 3x from 0 to 3. I only plug in 3. And it's 81 over 4 plus 27 and plus 9. So I expect to get 81 plus 4 times 27 and plus 36. So what is that? So this is 117, and so 225, is it 225 over 4? So this is what I expect to get. Not because I would like to fudge it or something, no, but I need to check my work, and this is just a quick check, okay? Then I have 3 preps. First of all is delta x, which is 3 minus 0 over n. The next one is xi, which is 0 plus I delta x, but since I start at 0, then it's 3I over n. And then f of xi, which means plugging this into the function. So 27I cubed over n cubed plus 18I over n plus 3. So having all these pieces, I can put the limit of the Riemann sum together now. So the area equals the limit as n approaches infinity. I will put delta x in front, 3 over n. And I have to apply the sum to these 3. 27 over n cubed, the sum of I cubed, plus 18 over n, the sum of I, plus 3, the sum of 1. Just to reduce the amount of work of writing. Okay? I know that this is n squared n plus 1 squared over 4. I know that this is n plus 1 over 2, and I know that this is n. So then I have limit as n approaches infinity 3 over n. 27 over n cubed times n squared n plus 1 squared over 4 plus 18 over n plus 1 over 2 plus 3n. Let's see if I can get rid of this 4. I can't with 27, but I will get rid of 2n. So the least common denominator will be 4. This is 2, so it needs a 2, and this is a 4n. So this is limit n approaches infinity 3 over n, 4n. So I have 27 times 4 with n squared 2n plus 1 plus 36 n squared plus 36 n and plus 12n squared. Now, I'm okay if you say, I know from here, I know that's going to be 98 plus 36 plus 12. I'm okay if you write 3 multiplied by 98 plus 36 plus 12 divided by 4. I'm fine. Because at this point in time, we know that it's the leading coefficient over the leading coefficient. I can use L'Hopital's rule if I want to, but it's n squared over n squared. So let's see what I get. And since I just became lazy, oh, this is, actually I shouldn't, because this is 110, 146, right? So 3 times 146 divided by 4. And if I'm not getting what I started with, and I'm not, 225, unless I made an error here. No, it's 117. Okay. Oh. I found one error. Okay. So it's 120 plus 36, right? So it's 156. Right? Am I correct? Okay, I will simplify by 2, and I get 284 over 2. Yeah, something, I went too fast somewhere. Let me double check my work now. So it was 27. Now I have to check everything. So 18i over n and then 3. Okay. And then I had 3 over n in front. 27n cubed, that's correct. Yes. Okay, then 18 over n, that's correct. And 3n, that's correct. Okay. So now 3 over n, 27 over n cubed. I removed an n squared. I still have an n squared plus 2n plus 1. I have a 27 times 4. Am I correct here? Oh, why did I multiply by 4? 4 was from above. I multiplied by this 4. It has nothing to do with anything. Okay, I got it. So it's just 27. There's no 4. You let me multiply by 4, and it's not your fault. It's not your fault, not your fault. But why did you let me multiply by 4? 4 is from something else. So this is 27. Okay. This needs a 2. That's correct. And this needs a 4. Okay, just this one got me confused. It was from something else. So then I have 3 multiplied by, and this is 27. That's why. Sorry. 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 Too close. Too close. Rows were too close. Okay, so this is 27. So this with 27 plus 36 is 63. 63 plus 12 is 75. Times 3. So this is 75. So that's 22. And that's what I had to come up with. Yes, so it works. So don't try to make that up. Of course, I realized that something was wrong. But I knew the answer from the very beginning. It took me a minute and a half to find the answer. Because mistakes like, shouldn't happen. But what happened here is I was, for some reason, multiplying by 4. And I should have not. That 4 was from something else. Very good. Are we moving on? Any questions on this? Yes, you can completely simplify it. So you will have 27n squared, and you'll have, the 75n squared, and then you'll have 2 terms with n and 1 free term. But when you apply L'Hopital's rule, or you think in terms of the fact that this is a same degree of a same degree and n approaches infinity, then you know what to expect. It's a leading coefficient over the leading coefficient. So you can fill in the gaps here, or just write this and I'm fine. Is that clear? Yes? Okay. So we're moving on to the integral from 1 to 5 from f of x dx if such and such. Is this problem clear, everyone?
We have
Yes.
the answer 225 over 4 or something.
Yeah. 225 over 4. It's right here. 225 over 4. Yeah, because it's 75, and 3 times 75 is 225, and the denominator is 4. Is that okay? Yeah. Don't write too close.